My dear students, today I am going to explain you some numericals in physics. The first question is a block of wood floats in water with 2/5 of its volume above the surface. Calculate the density of wood. The solution is let the volume of the block be V and density of wood be D. Therefore, volume of the immersed part in water is equals to V minus 2V by 5, and that is equals to 5V minus 2V by 5 equals to 3V by 5. Now, by the principle of flotation, weight of the block is equals to weight of the liquid displaced by the immersed part. So V into D into Z equals to 3V by 5 into 1 into Z, and since density of water equals to D equals to 1 gram per cm cubed. So here V into Z left and right both side it is, so that has been cancelled, and therefore D is equals to 3 by 5, that is equals to 0.6 gram per cm cubed. This is the answer. This is the density of wood that we had to calculate. Second question is a hospital uses an ultrasonic scanner to locate tumors in a tissue. What is the wavelength of sound in a tissue in which the speed of sound is 1.7 kilometer per second? The operating frequency of the scanner is 4.2 megahertz. M stands for mega hertz, and you know that 1 megahertz is equals to 10 to the power 6 hertz. So the solution is wavelength is equals to lambda equals to what that we have to calculate. V, that is the velocity, equals to 1.7 kilometer per second, and that is equals to, we will convert into meter per second, so we are multiplying it by 1000. So 1.7 into 1000 becomes 1700 meter per second. And frequency equals to F, that is equals to 4.2 megahertz, that is equals to 4.2 into 10 to the power 6 hertz. Now we know that V equals to F lambda, yes, and therefore lambda equals to V by F. So V value is 1700 by, and frequency is 4.2 into 10 to the power 6 meter, that is equals to 17,000, because this decimal has been removed, 4.2, so 10 came up, so it became 17,000, and this 10 to the power 6 came up, so it became minus by 42. And this is the formula that V equals to F lambda, that means speed of sound velocity is equals to frequency into wavelength. So it becomes 17 into 10 to the power 6 plus 3, because here 10 to the 17,000, so this can be written as 17 into 10 to the power 3. So bases are same, so power will be added, so it is 10 to the power minus 6 plus 3 by 42 equals to 17 into 10 to the power minus 3 by 42. After dividing 17 by 42, you get 0.405 into 10 to the power minus 3 meter. Now we are converting it into millimeter. So we will multiply it by 1000 because 1 meter equals to 1000 millimeter and 1000 millimeter means 10 to the power 3 millimeter. So we have multiplied it by 1000 and then we get 0.405 millimeter. This is the answer. This is the wavelength. Third question is pressure of a gas is 75 centimeter of mercury at 27 degrees Celsius. Find the temperature at which the pressure will be doubled if the volume is kept constant. Solution is here P1 equals to, that is initial pressure, is equals to 75 centimeter of mercury. P2, that is final pressure, equals to double of the initial pressure. So it is 2P1 and that is 2 into P1 is 75, so it is 2 into 75. That is 150 centimeter of mercury. And T1 equals to, that is initial temperature is 27 degrees Celsius. So it will be converted into Kelvin. So 27 plus 273 equals to 300 Kelvin. And T2, that is final temperature, we have to calculate. So here you find that volume is kept constant. That's why from pressure law, P1 by T1 equals to P2 by T2. This implies P1 value is 75, T1 is 300, and that is equals to P2 is 150 by T2 that we have to calculate. By crisscross multiplication, we get 75 into T2 equals to 300 into 150. And therefore T2 equals to 300 into 150 by 75. 75 to the 150, so it is being cancelled and we get 300 into 2 equals to 600 Kelvin. Now we are going to convert into degree Celsius. So from this Kelvin, we will subtract 273. So 600 minus 273, we get 327 degrees Celsius. This is the temperature that we had to find out. Thank you. If you like, please share and subscribe.